Good morning, all the students. How are you? I hope you all are blessed and fine. Now we are going to discuss about our the concept of our refraction at a plane surfaces. You know very well about that. Already yesterday we are discussed it. There is up to question number 7. Yeah, due to the refraction of the whatever the dust particles and gas layers are there. Okay, now due to that only there is all the whatever our stars are may twinkle. Okay, due to the refraction of that layers. Here now we are going to discuss about our and whatever our second part, that is only application of application concepts. Now in this application of concepts questions, there is what we have. The first question: a light ray incident on a liquid interface at 45 degrees and is refracted at 30 degrees. What is the refractive index of the liquid? Yes, for what angle of incidence will angle between the reflected ray and refracted ray be 90 degrees. Once again I am repeat it here. What the angle of incidence will the angle between refracted ray and reflected ray and refracted ray be 90 degrees. All the students, there is a question number 1 here. There is a problem, it is a given numerical problem. Here A and liquid interface is there. Here there is a incident ray is 45 degrees and refracted ray is 30 degrees. Yes, the angles are given. Now we have to know what is the refractive index of a liquid. Now the problem is like this. Okay, clear or not, all the students? Problem is like this here. What the problem we are considered? Here the problem is taken. Here the problem is taken as here like this here. Here it is a A, and now incident ray is a 45 degrees angle. The refracted ray is 30 degrees only. Here 30 degrees only. Clear or not all? Now we have to find out what is the refractive index of this medium. You take it is a N2, it is taken as N1. The refractive index of medium is N1, it is N2. The formula is written as what the formula? Yeah, N1 sin I is equal to N2 sin R. Written or not, it is equal to taken as N2 by N1. Okay, from this formula only we written it is N1 sin I is equal to N2 sin R. Okay, and now I is equal to how much? N1. N1 is how much then? It is a 8. That's why N1 is equal to 1. Okay, clear or not, all the students? I is equal to taken as 45 degrees. R is equal to taken as what? R is equal to taken as somewhat 30 degrees only. Now it is written as 1 into sine 45 degrees is equal to N2 into sine 30 degrees. Already I am given the value of sine 45 how much? Sine 45 is written as 1 by root 2. Okay, clear or not all of you? And sine 30 is a 1 by 2. 1 by 2. Okay. I hope you got it, this information. Now, where it is in 10th class, it will be there about these angles. Okay, now it is written as what it is here. You substitute these values, both the values here. Now, n2 is equal to become what, Nana? n2 is equal to become sine 45 by sine 30 here. Now, it is also written as n2 is equal to also written as it is how much? How much it is? Yeah, 1 by root 2 by 1 by 2. Now, n2 is also written as 2 by root 2. Written or not it is? 2 by root 2. It is also written as root 2 into root 2 are 2 written as like that. This one and this one cancel. n2 is equal to root 2, that is only 1.414. Okay, in this way you have to calculate the number 1 in the first question. The second question is, for what angle of incidence will the angle between reflected ray and refracted ray be 90? That is only what actually, that is only here critical angle. It is a what? It is only critical angle. You know my reason that is n2 by n1 is equal to taken as sin C here simply. Okay, that is only or not. That information is nothing but refracted ray to the our reflected ray angle is a 90 means it is a angle. The angle of incidence is a critical angle. Here sin C is equal to taken as 1.414 by 1. Yes, that is only called as C is equal to sine inverse of 1.414. Okay, 1.414. That is equal to taken as what? 57 point. Okay, clear or not all the students? 54.7 degrees. Simply, that is a critical angle. You have to find out. Okay, critical angle only. I hope you got it. That is only we have to find out the critical angle only. Okay, yes. Yeah, don't write any related matter. Okay, you are also going into the black if you write a related matter to our topic. Okay. Please be concentrated. The light is not a easy topic to like remaining. Okay, na? Yes. And compulsory you all read. You should compulsory imagine your position with the light rays. Okay, at that time only you get the answers and everything. Okay. And now come to here. Yeah, actually it is a sine inverse. Sine inverse. You don't know about these values. Actually, there it is a sine inverse values. These all are sine inverse values. Okay, sine inverse, it is a sine theta is equal to somewhat 90 degrees. Now it is the theta is equal to written as sine inverse of 90. Like that you have to written. Okay, this is the you get in your mathematics of a 10th class. Don't bother about that. Okay. Yeah, you come to here. The next further our concepts. Yeah, now board is clear all the students? Yeah, come to our second component. What is that? Second one. Here whatever the in what cases does the light ray not deviated at the interface of the two media? Okay, now at what cases the light rays not deviated? In what cases the light ray not deviated? Yes, here not deviated at the interface of two media. Any of the student please give the answer to me. At what cases? At what cases there is our light ray not refracted or not deviated at interface. Yeah, there is a what? At what cases, Nana? There is, it is a not deviated at what cases? Here there is a N1 is equal to N2. At that time also it is not deviated. I hope you got it. N1 is equal to N2. At that time there is our ray is not deviated. I hope you got it. When there is our light ray is not deviated, when there is a N1 is equal to N2, there is our light ray is not deviated. The medias may different, but there is a refractive index is the same. The light ray is not deviated from its interface. The velocities of light rays are not changes. Velocities of light rays are not changes. When the light ray enters from one medium to the another medium, at that time also the light rays are not deviated from its original path. Okay, clear or not, all of you? Yes. And here mainly these two things are only may get for us. Just they are asking about the not deviated at the interface of the two medias. When it is a possible, yeah, it is a possible like that only. Suppose you take a vinegar, yes, vinegar, and in a particular glass tube you take a vinegar, yes, and you take one more glass tube, small glass tube. In that vinegar, may not appear that vinegar, the difference is not appear for us. Okay, they looks like that only. Okay, clear or not, all of you? Yes, you take a vinegar in the glass, and this is the totally vinegar you have to take. Suppose in that one you take one more glass tube here like that. It may not appear like a glass tube when you add the vinegar to it. Okay, why? Because the vinegar refractive index and this glass tube refractive index are same. Got it or not? I hope you got it, all the students. And now there is one more concept, that is the next concept we have taken here. That is the what here? Third one. Place an object on the table. Look at the object through the transparent glass tube, glass slab. You observe that it will be appear close to you. Draw a diagram to show the passage of a light ray in this situation. Okay, clear or not, all the students? Look at the object through the transparent. Okay, clear or not, all the students? Now here we take one of the glass tube like this. You take object here, one of the object here like one flower. Okay, clear or not, all the students? Yes. Now the light ray comes through this. Okay, clear or not, all? Yes, light ray comes like this, and automatically, yes, it will be bended and it will be moves like this. And here it will be, in case it is passes through like this here. Okay, now, yes, and it will be shown what here? It will be shown at a nearby actual distance. Why? Because you know very well, always the light ray passes through in which path? Light ray is always passes through the low time taken path. Okay, that's why automatically it is appear for us nearer than the actual distance. Okay, clear or not, all the students? Yes, that is only we have to draw here. Otherwise, you know very well. Okay, now when you take a glass of water, okay, like this glass of water, you have to take here the kind may here, it will be taken kind may here, and you observe this kind like this situation. It is a air and it is a water. The kind is not appear for us here. The kind is appear for where? Actually, the kind is appear here only for us. The kind is not appear for here for us. Okay, why? Because the light ray is not enter through this particular, yes, not enter through this particular distance. It will be what? Bended towards the normal. That's why it is appear here only, not appear here. Okay, now like that you explain. There so many possibilities are there. You go through like this. Okay, clear or not, all the students? And write the ray diagram for that light ray when it is entered through the particular glass slab. Okay, and now there it is a what we taken automatically. You have in this our textbook also. Clear or not, all the students? In this textbook also it will be there. Okay, in case you are observed through this, in case undeviated ray may be get for us. Undeviated ray may get for us. Okay, now undeviated ray, it will be passes like this. It is a long distance, it will be there. Okay, now yes. And one more thing here, our vertical shift diagram is also indicates what? This vertical shift diagram is also indicate near observation. Okay, yes, that will be there for a third question answer purpose. Now come to your fourth question answer. Okay, now in the second bit, fourth one, what is that? Why does a diamond shine more than a glass piece cut to the same shape? Okay, why? Because the glass is contain the refractive index in the range of 1.3 to the 1.7 maximum, but our diamond refractive index is the what actually? In the diamond refractive index is 2.42. Because of this high refractive index, light ray undergoes the more refraction. When it is a more refraction, automatically when it is a fall on a second surface, it is a become that incident ray of a first refraction. Yes, that is a become the what? Incident ray for the second surface. That incident angle may equal to critical angle. When it is under critical angle, it undergoes the total internal reflection process. In the glasses, in the normal glasses, may not get the total internal reflection process. In our diamond, there is a total internal reflection process will be get for us. Okay, suppose there is a what is going on, there is it is a shape of a diamond. You know very well about this. Okay, clear or not, all of it is made by the normal glass. Now it is made by the diamond material. You know very well what is the diamond material. It is a carbon. It is a carbon. It is not a carbon. It will be glass is made by the aluminum oxides. Aluminum oxides or magnesium oxides. That thing contain a carbon material. It is a contain 2.42 is the refractive index. It is only contain 1.3 to 1.7 refractive index only. Then what is going on when it is taken as a glass? Suppose this is the incident ray. Okay, this is the incident ray. Now the normal is a become what? Normal is a become may like this here. This is the incident angle. When you extended this normal, automatically it is a bended towards the what? Bending towards the normal. It is bending towards the normal like this. It is in case a normal. Now the next the ray is a moves like this. Okay, clear or not, all of you? Whatever this angle is there, may again one more time there is we have possibility to refract like this. into the same media, it is possible to refract like this? No. It is propagated out from it here, like this. Okay, clear or not all of you? It is one of the transparent media, it is another transparent media. Whatever the incident angle, it is a fall on the second surface, it may not equal to the what? Critical angle. Why? Because less refractive index is only there. But in our, whatever our diamond is there, it may not like that here. Okay, this is the incident angle. Okay, clear or not all the students? This is main incident angle. Yes, it will be bended like this towards the normal. There is a whatever this, it will be there. It may equal to the what? Critical angle. It is may equal to the critical angle. Why? Because more refractive index is there. More refractive index is there. Like this, more refraction may possible. Okay, because of this, it is reaches to here. It may reaches to here, and this is may become to the what? This incident angle. This is become the normal. This incidence angle is equal to my critical angle. It is totally again reflected into this one only. 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 It will be may not occur. For our incident light ray, whatever enter into the diamond, it behaves like this. But here it is not behaves like because. Why? Because the diamond refractive index is more than this glass. In the glass, just this is entered and as well as it is a fall on the second surface, may it is emitted out from that. Okay, maybe lateral shift is only occur in the glass slab. Already we are discussed. Only lateral shift occur here. But here not like that. Here lateral shift is not only occur here, there is a internal reflection is also occur in the diamond. Okay, clear or not all of you? Simple concept in one word. If you write in a one word this answer, in the diamond the total internal reflection process is going on. In the glass there is a what? There is a no total internal reflection process due to the high refractive index of the diamond. This is a one word answer. If you want to explain in a 4 marks, this purpose you have to draw these diagrams. Just you write here this diagram, you write this you draw this diagram for the diamond. You explained it. How you explain this question? Yeah, when the light ray is incident on the glass slab, otherwise the glass like a diamond shape. Okay, now when it is enter into this, just there is a what? First refraction is occur. Due to that refraction, the light ray bending towards the normal, and it is a fall on another surface. Okay, now it is not equal to the whatever the refracted ray which is come from the first surface. It is a become incident ray for the second surface. That incident angle may not equal to the critical angle. That's why it is may emitted from the second surface when you take a glass. But due to the high refractive index in our diamond, whatever the first refracted ray is there, that is incident with the critical angle on the second refracting surface. Because of that again the light ray enter into our diamond media only. That is total internal reflection. That is due to total internal reflection. And these type of total internal reflections, number of times our light ray whatever initially enter into the diamond, that may not go out from diamond. Why? Because every time the light ray undergoes the total internal reflection when it is a fall on a different diamond as well as the glass. Got it? Next concept here. Come to third bit. What is the third bit is there? Higher order thinking questions are there here. Why is the difficulty to shoot a fish swimming in a water? Why, tell me? Yeah, there is a water. Actually, it is a water. Here, suppose the fish here, fish is there here. Clear or not all the students? Here the fish is there here. Okay, got it or not? We want to shoot here some for our eye it will be appear. Okay now? Yes, we observed from our eye, but it is not actually it is appear. Actual fish position is here. Okay, but whenever the rays or whatever the light rays come from the fish. Okay now? Yes, the light rays come from the fish. It is a what? It is a become the normal for the surface. It is a normal for the surface. Now the light rays come from the fish like this here. It is a what? It is a denser media. It is a what? Rarer media. You know very well. After refraction, it may not appear. It is may in case actually the position of that fish in case undeviated ray purpose in this direction. But for it is appear for us where when it is our eye at that time only it is appear for us. Okay, clear or not all the students? I hope you got it. There is when you take it is a normal. It is a normal. Yes, when our eye it is there at that time only it is appear. But actually there is a what when you are take it a straight line, may it is appear for us where actually in this particular position. Okay, now may not appear in this particular position. Why? Because light ray is deviated. Actually, it is in this position. For us, it is appear at where? In this particular position. That's why it is not possible to shoot easily. It is possible to shoot easily that whatever air particles are there, whatever the particles are contained in the air. Why? Because our eye is also in air and that particle is also in air only. So easily we have to find that whatever the particle are there in air. But it is not easy when it is in another media. Why? Because light ray is bended due to the refraction. There is whatever the actual position is there, may not that is the actual position of the fish. Okay, that's why it is not possible to easy to catch the that particular fishes. Yes, in that whatever it is inside the water. Okay, clear or not all the students? And now explain why a test tube immersed at a certain angle in a tumbler of water appears to have a mirror surface for a certain viewing positions. Okay, clear or not all the students? Once again I repeated the question. Explain why a test tube immersed at a certain angles in a tumbler of water appear to have a mirror surface for a certain viewing position. This is also same thing. Okay, clear or not all the students? When you are take a test tube, in case you are taken not at a straight manner, you want to bend it is somewhat angle. Okay, clear or not all of you? Suppose you take a tumbler like this. When you take it is like in the water. Okay, it may not appear like that. It may appear like this here. Somewhat angle may get for us. Because of that, when we are make it is an angle, automatically due to the refraction, where up to where it is immersed, okay, now it will may get for us. Otherwise, may not get it in the correct position of our test tube. Okay, clear or not all of particular glass tumbler media, and may we not get the position of our the test tube are not get in a same position of actual where it will be placed. Clear or not all the students? And now come to here, when we sit at a campfire, object beyond the fire are seen swaying. Give the reason for it. You know very well. Okay now? Yes. There is a what? Because of refraction only. There is a what? Our light ray first enter from air. Then it is enter into the fire. Then it is enter into that substance. Okay now? You know very well. Yes, due to the dew. Okay now? Dew is also contain what? Vapor nature. Means what? A water nature. The refractive index are varies here. Because of that only there our light rays undergo the refraction. There is a may it will be looks in the form of a saying. Okay. Yes, this is only the things we are have in our higher order thinking question. Next come to here multiple choice question. which of the following is the Snell law? You know very well that is the Snell law is nothing but what we have taken n1 sin I. Here n2 by n1 is equal to sin r by sin I. n1 by n2 is equal to, the answer is B. Yes, answer is what? No, answer is B here. n1 by n2 is equal to taken as sin r by sin I. Sin r by sin I. This is only called a Snell law. Got it? And now there is one more thing, that is the refractive index of the glass with respect to air is 2. Then the critical angle of the glass of air is interface. Okay, already you know very well the refractive index with respect to the air of the medium is 2, means what? It is become 1 by 2. There is a what? Air is a 1 and the refractive index of the medium is a 2. Yes, that is only n1 by n2 is equal to taken as what? Here n1 by n2 is equal to taken as sin C. Okay, clear or not all of you? That is only the formula. From this formula 1 by 2 is equal to sin C, means the critical angle is 30 degrees. Okay, clear or not all the students? It is a what? 30 degrees. Why? Because sin 30 is equal to what? Sin 30 is a, yes, 1 by 2. Okay, answer is yes, C. Second answer is C. Total internal reflection takes place when a light ray travels from, when a light ray travels from, where it will be travels from? Denser medium to rarer medium. It is a possible when it is a denser medium traveled from where to where? Here denser medium to the rarer medium to the denser medium, or rarer medium to the rarer medium? No, it is a denser medium to the denser medium. Okay, clear or not all of you? Here the question once again, total internal reflection place the light ray travel from where? Travel from here, there is, it is a enter denser medium and again it is enter into the denser only. Clear or not all the students? Again it is enter into the denser only. That is only called total internal reflection. This is only called what? Total internal reflection phenomena. Got it or not all the students? I hope you got it. Yes, this is the total internal reflection phenomena. Light ray enter from a denser medium to again denser medium only. Yes, the answer is D, due to the total internal reflection. Next, last components. Yeah, so many are there here. Okay, our time is completed. Yes, if the angle of incidence is equal to critical angle, then the angle of refraction is should be 90 degrees. You know very well. Angle of refraction is 90 degrees at that time only. One thing, the condition is the what? R is equal to 90 degrees. I is equal to should be C. C. That is the C is what? Critical angle. This is only the condition we have to take in for it. Got it? Yeah. Now one more component, that is only fourth one, internal reflection. Okay, now mirages are best example for the total internal reflection. And next to come to here, there is this question already I am given in that our last examination also. Here there is about refractive index of ice, benzene, ruby and kerosene are 1.31, 1.50, 1.71, 1.44 respectively. Travels slowly. Where the refractive index is more, at that place there is travels slowly. That is about actually ruby. Answer is C. Okay, clear or not all of you? The relative refractive index of water with respect to the air is 4/3. Then the relative refractive index of the air with respect to water is become 3/4. Okay, that is answer is D. Yes, and in the glass lab experiment it is a given. Which one is the emerging ray here? The emerging ray here CD. The emerging ray is a what here? CD. Why? Because there is a light ray enter as a AB and it is a B to C is again transmitted ray, and C to D it is a become emerging ray. Okay, this is only about our multiple choice questions and somewhat experiments and projects works are there. Yes, with this our lesson completed. Okay, now if we have a classes, yes, and on Monday also, okay, I will explain the remaining thing. Okay, clear or not? Thank you students, bye, take care.